let's take stock now. Remember, we wanted to compute the probabilities Sn, and we determined as our first slogan that if we know the F's, then we know the S's. We punted the ball downfield and said, well, to compute the F's, if we know the U's, then we can compute the F's. And now to compute the U's, we say, if we know the early values of U, then I can compute the later values of U. And now it's a question of simply assembly. There's nothing particularly edifying about this assembly. Right? This is algebraic, and you're going to get the numbers together and see where they go. But at the end of the day, a beautiful story is going to emerge like a butterfly from a chrysalis. Right? So bear with me, and we'll go step by step. So our first order of business is to compute the probabilities un for every value of the index n, where un represents the probability that there is a success run of length 5 which is occurring at trial n. Now here's what we know as our boundary conditions. You cannot have a success run of length 5 terminating in the first 4 trials, so u1 through u4 are manifestly 0. What about u5? Well, we know what u5 is, but let us test our formalism. We've got a formula sitting above us. Let's plug it in with n equal to 5. And if you plug in n equal to 5, well, you get an expression on the right, which is 2 to the power minus 5, from which you subtract away terms involving u1 through u4. But u1 through u4 are all 0. They all vanish quietly, like the snows of yesteryear. And what remains is simply 2 to the power minus 5. What about u6? Plug in n equal to 6, and now we've got an expression on the right, which is 2 to the power minus 5, from which you take away various terms from u2 through u5. Well, but u2 through u4 are 0, they vanish. u5 we've just discovered is 2 to the power minus 5, in consonance with an immediate and direct analysis, and therefore u6 is 2 to the power minus 5, from which you take away 2 to the power minus 6, and an elementary reassembly and factorization shows us that this is exactly 2 to the power minus 6. There's only about a 1 in 64 chance that you get a success run occurring on the 6th trial. What about u7? Just one more to fix ideas. Put an n equal to 7 in there, work your way through. The only terms that survive on the right are from u5 and u6, but we've already discovered these values in the previous step. And that's the essence of the recursive argument. Plug those in, and we find, u7 is also 2 to the power minus 6. You might want to give this a little thought. Why are u6 and u7 both the same? Is there something wrong? If you think about it for a little bit, you realize that this is a consequence of the fact that if there is a success run to occur at all, there can be only up to one success run in the first 9 trials. And therefore u6, u7, and so forth, up to u9 are going to have to be the same. Now we can understand how to build this forward. From u7, you go to u8. From u8, you go to u9. Of course, doing it by hand is tedious and not at all edifying, but this is the kind of task that a digital computer excels at. We simply write in one line of code which says, compute this recursively. And you do it, and out comes a table like this. I've given you the fractions here explicitly to emphasize 2 things. One, we're actually computing this exactly, not to some decimal approximation. We can actually get the exact rational value for each of these probabilities. But of course, a big fraction like u20 is hardly edifying, right? So we'll eventually want to look at it in decimal format to get a better idea of what's going on, and we shall. Right? The other thing to note is that in the denominator, we have powers of 2. And that's going to arise because we're dealing repeatedly with the toss of a fair coin, and we're going to have products of 1/2. Okay. Thus far, thus good, so good. What we've discovered is a systematic recursive process by which we can compute all the values un if we wish. Now we've got this whole sequence of values of un. What next? Well, the next step is to go on and compute the first success run probabilities. That comes next.